NVIDIA's vision for the future of AI. Imagine a world where machines don't just think, they act. From self-driving cars navigating complex city streets to robots that can assist in daily life, NVIDIA is paving the way for AI to move beyond screens and servers into the physical world. At CES, NVIDIA's CEO Jensen Huang revealed the roadmap for this bold evolution, introducing us to the concept of physical AI. What does this mean? Unlike generative AI that crafts text or images, physical AI is about embedding intelligence into devices that can interact with their environments in real time. Robotics, autonomous vehicles, and industrial automation are no longer futuristic dreams. They're here and rapidly advancing. NVIDIA isn't just theorizing, they're building the infrastructure to make this possible. Their platforms, like NVIDIA Omniverse, Cosmos, and the latest Thor processors, are setting the foundation for what's next. With an estimated 1 trillion miles driven annually across the globe and countless tasks ripe for automation, the potential for physical AI to reshape industries is staggering. This isn't just about convenience, it's about solving real-world problems at scale. NVIDIA's innovations promise safer roads, more efficient factories, and tools that can handle the complex challenges of modern life. Stay tuned, because what you're about to discover could redefine how AI integrates into the world around us. Let's dive into the details. NVIDIA's roadmap for AI evolution is a journey from the digital to the physical. At CES, Jensen Huang detailed the 3 key stages of this transformation: generative AI, agentic AI, and now the era of physical AI. This progression isn't just about improving AI's capabilities, it's about fundamentally changing how machines interact with the world. Generative AI, which powers tools like ChatGPT and DALL-E, is the foundation. These models produce text, images, and even code based on user input. Agentic AI, expected to dominate this year, is the next leap. AI systems that proactively set goals, reason about their environment, and act autonomously. But the real game changer is physical AI, which focuses on embedding these capabilities into machines that exist and operate in the real world. Physical AI isn't just an extension of digital intelligence. It requires a deeper understanding of physics, spatial relationships, and cause and effect dynamics. For example, an autonomous car needs to process real-time data about traffic, weather, and road conditions while predicting outcomes. Similarly, robots in factories or homes must grasp concepts like object permanence and friction to perform tasks effectively. NVIDIA's platforms like Cosmos and Omniverse are at the forefront of this shift. Cosmos serves as a world modeling platform, generating synthetic data to train AI systems in realistic environments. Meanwhile, Omniverse allows developers to simulate geospatially accurate physics-based scenarios, bridging the gap between virtual and real-world applications. This is the next frontier for AI, a transition from digital mastery to physical innovation. It's a future where machines will not only compute, but also interact, adapt, and evolve alongside us. The leap from digital intelligence to physical capability requires a completely different approach to AI development. At the heart of this transformation is the concept of world models, AI systems that can understand and predict real-world dynamics, like gravity, inertia, and object permanence. Jensen Huang described how NVIDIA Cosmos is redefining how we create these world models. Cosmos is more than a simulation tool. It's a platform for building world foundation models, the equivalent of language models, but designed for robotics and autonomous systems. These models don't generate words or images. They generate realistic simulations of environments, behaviors, and interactions that machines must navigate. Take, for example, a self-driving car. It must understand how a slippery road affects braking, or how a pedestrian's movement might change unexpectedly. These scenarios require an AI system that isn't just reactive but predictive. Cosmos uses advanced tokenization methods to turn real-world environments into datasets that can be processed by AI systems. These synthetic environments are built with the help of NVIDIA Omniverse, which allows developers to create hyper-realistic physics-based simulations. But why does this matter? The physical world is messy, unpredictable, and expensive to replicate for training purposes. By generating synthetic data with Cosmos, developers can train AI models on billions of scenarios, including rare or dangerous events that would be impossible to capture in real life. This means safer self-driving cars, more reliable robots, and AI systems capable of handling complex real-world tasks. This blend of simulation and real-world dynamics is the foundation of physical AI, bringing machines closer to understanding and interacting with the physical world like humans do. NVIDIA is not just imagining this future, they're building it, one world model at a time. Creating robots that can seamlessly operate in the real world requires more than just advanced hardware. It demands vast amounts of data and intelligent systems that can learn, adapt, and improve. This is where NVIDIA Isaac Groot steps in, offering a comprehensive framework for developing humanoid and general-purpose robots. Robotics faces a unique challenge. Real-world data is incredibly expensive and difficult to collect. Imagine training a robot to pick up fragile objects without breaking them. Each mistake not only risks damaging the object, but also the robot itself. Isaac Groot solves this by leveraging synthetic data and simulation. Using tools like teleoperation, skilled operators can control virtual robots in risk-free environments, capturing precise motion data without ever touching a physical machine. Here's how it works. Developers use Groot Teleop to remotely control a robot's digital twin through devices like Apple Vision Pro. These demonstrations are recorded and then multiplied into massive datasets using Groot Mimic. But the real magic happens with Groot Gen, which uses NVIDIA Omniverse and Cosmos to apply domain randomization, generating variations in lighting, environments, and edge case scenarios to create exponentially larger training datasets. This approach dramatically accelerates robot training. For example, teaching a robot to perform a task that would traditionally require thousands of hours can now be achieved with a handful of demonstrations and AI-driven data augmentation. The result? Robots that can learn faster, adapt to diverse environments, and execute complex tasks with precision. Isaac Groot isn't just about building robots. It's about creating a scalable system for robotics development. By combining simulation data pipelines and NVIDIA's AI technology, it's enabling a new generation of robots to operate not just in labs, but in homes, factories, and cities. This is how robotics transitions from experimental to essential, powered by the tools NVIDIA is pioneering. Autonomous vehicles, AVs, are no longer a vision of the future. They're here, and NVIDIA is playing a pivotal role in their evolution. At the core of this revolution is NVIDIA Thor, a groundbreaking processor designed to handle the immense complexity of self-driving systems. Thor is a robotic supercomputer capable of processing enormous amounts of sensor data from cameras, radars, and LiDAR systems. These sensors feed real-time information about the vehicle's surroundings, which Thor converts into actionable insights. It uses AI-driven models to predict paths, avoid obstacles, and make split-second decisions. Compared to its predecessor, Orin, Thor offers a staggering 20 times improvement in processing power, making it a game-changer for the AV industry. But hardware alone isn't enough. Autonomous vehicles require data, lots of it. NVIDIA addresses this with tools like Omniverse and Cosmos, which simulate billions of driving scenarios. These platforms generate synthetic data, including rare edge cases like sudden weather changes, unpredictable pedestrians, or multi-car accidents. This data is fed into training systems, creating AI models that can handle real-world complexities far better than human drivers. What makes NVIDIA's approach unique is its end-to-end ecosystem. From data collection and model training on DGX systems to in-car execution on Drive AGX supercomputers, NVIDIA provides all the tools necessary for AV development. This integrated system allows automakers like Toyota, Mercedes-Benz, and Tesla to deploy safer and more reliable self-driving technologies. The implications are enormous. Autonomous vehicles promise safer roads, reduced traffic, and a more efficient transportation system. With over 1 trillion miles driven globally each year, the potential for this technology to transform industries and daily life is immense. As NVIDIA continues to push the boundaries with Thor and its AI platforms, It's clear that autonomous vehicles are not just a trend, they're a cornerstone of the future economy. The AV revolution is here, and NVIDIA is driving it forward. Factories of the future won't just be spaces filled with machines. They'll be intelligent ecosystems, powered by AI and guided by digital twins. NVIDIA is at the forefront of this transformation, creating tools that make factories more efficient, adaptable, and precise than ever before. A digital twin is a virtual replica of a physical environment, complete with real-time data and simulation capabilities. NVIDIA's Omniverse platform enables manufacturers to build these digital twins with unmatched accuracy. Using inputs like CAD models, sensor data, and AI-generated environments, factories can simulate their operations before deploying changes in the real world. This technology allows for infinite scenario testing, helping companies optimize workflows and predict outcomes without disrupting daily operations. Take Keon, a warehouse management solution that uses NVIDIA Omniverse to simulate robotic fleets in a digital twin of a warehouse. These simulations can predict key performance indicators like throughput, efficiency, and utilization. For example, the digital twin can test how adding more robots might impact order fulfillment speed, or how seasonal demand surges could be managed. This ensures that every operational change is vetted for success before it's implemented. What makes NVIDIA's approach revolutionary is its ability to scale simulations using tools like Cosmos. By generating synthetic data, Omniverse can create countless variations of warehouse layouts, environmental conditions, and robotic interactions. This diversity of data enables AI models to learn and adapt to even the most complex scenarios. The impact is profound. Factories with digital twins can reduce downtime, cut costs, and improve safety. More importantly, they can adapt quickly to changing market demands, ensuring resilience in a volatile economy. With NVIDIA's AI-driven tools, the age of smart factories isn't just on the horizon, it's already here. As industries worldwide adopt this technology, NVIDIA's digital twin solutions are proving to be a cornerstone in the next industrial revolution, redefining how we build, produce, and innovate. One of the greatest hurdles in AI development for robotics and autonomous systems is the need for vast amounts of real-world data. Collecting this data is not only time-consuming and expensive, but also limited by the unpredictability of real-world conditions. NVIDIA's solution? Synthetic data generation, a revolutionary approach that could change the game entirely. Using platforms like Cosmos and Omniverse, NVIDIA creates realistic physics-based simulations that mimic real-world environments. These platforms generate billions of scenarios, ranging from routine situations to rare edge cases that would be nearly impossible to capture in real life. For example, training an autonomous vehicle to handle a sudden tire blowout or a robot to operate in dimly lit environments becomes significantly easier with synthetic data. But what makes synthetic data so powerful? It's not just about volume, it's about diversity. NVIDIA's tools can simulate variations in weather, lighting, object appearances, and even unexpected events like equipment failures. This ensures that AI models are trained on a comprehensive dataset, preparing them for nearly any situation they might encounter in the real world. The benefits don't stop there. Synthetic data reduces the reliance on costly and risky real-world testing. For instance, testing a robot's ability to handle hazardous materials can be simulated safely without endangering workers or equipment. Moreover, this data can be generated faster and at a fraction of the cost compared to traditional data collection methods. In the context of autonomous vehicles, synthetic data has been transformative. NVIDIA's AI Data Factory uses synthetic driving scenarios to train models on billions of virtual miles, amplifying the effectiveness of real-world training by orders of magnitude. This approach bridges the gap between simulation and reality, enabling safer and more reliable AI systems. By leveraging synthetic data, NVIDIA is unlocking new possibilities for AI development, ensuring that machines are not just reactive, but robustly prepared for the complexities of the physical world. It's a technology that promises to accelerate progress across industries, from robotics to transportation and beyond. As NVIDIA pushes the boundaries of AI, the ripple effects will be felt in every corner of daily life. From the way we commute to how products are manufactured, distributed, and consumed, the integration of AI into physical systems marks the beginning of a profound transformation. One of the most immediate impacts will be in transportation. Autonomous vehicles, powered by NVIDIA's processors and platforms, are set to redefine how we travel. Imagine a world where commuting is safer, faster, and stress-free. No more worrying about traffic, bad weather, or distracted drivers. With billions of miles simulated through tools like Cosmos, these vehicles will be trained to handle scenarios most humans would never encounter, making them not just competitive but superior to human drivers. In manufacturing and logistics, AI-powered factories and digital twins will revolutionize production efficiency. Companies will be able to simulate and optimize entire supply chains, ensuring that resources are allocated with precision and waste is minimized. This is particularly relevant in an era where sustainability is a global priority. Robotics, too, will become a part of everyday life. From assisting in elder care to performing dangerous industrial tasks, robots equipped with NVIDIA's Groot framework will fill roles that were once thought impossible. These machines will not only be efficient, but also adaptive, learning and improving as they interact with their environments. Even our cities stand to benefit. AI-driven systems will improve infrastructure planning, energy management, and emergency response, creating smarter, more resilient urban environments. For instance, autonomous delivery fleets could reduce urban congestion while improving last-mile logistics. But the real significance of this AI evolution is its ability to free up human potential. By automating repetitive, dangerous, or highly complex tasks, AI allows people to focus on creativity, problem-solving, and innovation. The age of physical AI is here, and NVIDIA is at its helm. As these technologies become more integrated into our lives, they won't just change how we interact with machines, they'll redefine what's possible for humanity. It's not just the future, it's the beginning of a new era. The revolution of physical AI, led by NVIDIA, isn't just about technology. It's about reshaping how we live, work, and innovate. From the unprecedented advancements in robotics and autonomous vehicles to the transformation of factories and urban environments, AI is becoming a cornerstone of progress. At the AI Watchmen, we're here to keep you informed and inspired by these groundbreaking developments. NVIDIA's journey, from Cosmos to Thor, and from Groot to digital twins, is a testament to how rapidly technology is advancing. These innovations are not just concepts, they're real, tangible solutions that will impact every aspect of our lives. So, what's next? As these technologies roll out, we'll be here to break them down for you. What they mean, how they work, and why they matter. Subscribe to the AI Watchman to stay ahead of the curve as we explore the future of AI and its ever-growing influence on our world. The future isn't just arriving, it's being built right now, and together we'll watch it unfold. Don't forget to like, share, and subscribe for more deep dives into the world of AI. See you in the next video.